we finish up with two things. One thing you should be able to understand and get. Like literally, I could ask you a question about distance, and many of you would be able to figure it out. But I'm going to tell you a different way to do it as well. And then another thing is going to be completely new. It's not this. We already did this. This is how I like structured things in the past. But this year, I'm going to give you a new understanding of average. So two little things to tie this unit in a bow. Okay, first thing is distance versus displacement. Now, let's say I have a dude who starts at a position of 0 times 0. So x of 0 is 0. And let's say I know the velocity of the dude is positive for 4 seconds, and then negative for 4 seconds. Whatever, fine. So dude's moving to the right, my position's increasing, my position's decreasing. Now we know that if I had an equation for velocity, I could find the area under it. The area under our derivative tells us how much we're going up, how much we're going right, or how much we're going down. And let's pretend I found that the area from 0 to 4 under V was positive 6, and that the area from 4 to 8 under V was negative 12. So that means I'm moving to the right 6, and I'm moving to the left 12. Now, if I ask you, what is your displacement from 0 to 8 seconds? Tell your neighbors what the answer would be. Now, this is the displacement over the entire interval. It's important to remember that. Tell your neighbors, what's the displacement from 0 to 8? I heard some people understand, some people don't. Yeah, the displacement's negative 6. What is that? That would be the area from 0 to 8 under V. And you'd add this 6 and this negative 12 together to get negative 6. Or if you think about going to the right 6 and then the left 12, my dude ends up 6 units to the left of where he started. That blue line is our displacement. Okay, so the displacement is negative 6. What's the distance, though? What's the distance that the guy traveled? 18, right? And you guys like naturally got that number because it's like, oh, if you go right 6 and left 12, well, 6 plus 12 is 18. Yes, distance does not care about direction. Velocity does. And displacement does. Yes, and that's why it's so important to understand what displacement means. Displacement is how far we are versus where we started. You know, it's not how much we travel. How far at t equals 8 we are from t equals 0. Okay, and now the process that you guys did to get this distance of 18 was the following, and I'm going to give you just a quick example with a graph of it. Here's my velocity, and this is going to be an easy way to do it. My velocity is negative 2t plus 4. I'm talking about the displacement from 0 to 4 seconds, and the distance from 0 to 4 seconds. Now, we could, if this was not a calculator question, analyze the signs of my velocity, figure out velocity changes at 2, which means I'm moving to the right until 2, to the left afterwards. My position is increasing and decreasing. This is the derivative position. We could, without a calculator, find those displacements, which means if I don't have a calculator and I want to find the displacement from 0 to 2, what do I have to do if this is a no calculator question? Very good. This is very, very important, guys. Remember this integral? This to your calculator means accumulate. And it's helpful that my calculator uses that notation for accumulate. So to your calculator, it means accumulate. To you, Mr. No Calculator person, what does this notation mean to you? Take the antiderivative. It's very important. If you don't have a calculator and you want to find a displacement, remember, you must take an antiderivative. A lot of students forget about this because we've been used to just plugging stuff into calculators and getting answers right away. And I can, without a calculator, get -4 plus 8 plus c minus 0, which is 4. Okay, so that means I moved to the right 4. And I could do that also from 2 to 4 if I wanted to. But what we will find is that, like, here's the visualization of velocity. Using geometry, which we will do next unit a lot more often, we can see that that area, the triangle worth of area, that's 4. So here's the 4. I could just like give to you, but you can kind of like be able to calculate that. And we'll use that in the future if we have straight lines. And we would be able to find without a calculator, but now we can visually see it, that the area here from 2 to 4 is -4. So if I did the same calculations from 2 to 4, I would get -4. Now, if I asked you what is the displacement overall, you'd say, well, Mr. Mester, if you go to the right 4 and then you go to the left 4, or if you add up these areas, you get a displacement of 0. But you guys know what you would do to find the distance is like you would take the positive displacement you got, keep it positive, but then you would take the negative displacement you would get, make it positive. Now, if this is a negative value, I could just subtract, and I would get 4 minus -4. Okay? And that gives me that A. All right, so displacement, remember, still 2 ways to find it. A to B of v dt. Your calculator accumulate v. It does v times t. That's one way to find a displacement. Your way is to take the antiderivative, plug in b, plug in a. This is the no calculator method, using this notation to mean antiderive rather than accumulate. And again, this is like you change in position. Distance involves displacement. If your displacement is positive, keep it positive. If your displacement ends up being negative, you're going to subtract your displacement so that it becomes a positive distance. Or you'll take the opposite of it so you can add a positive distance. This is like what you guys naturally did. You said right 6, left 12. Instead of 6 plus -12 to get your displacement of -6, you did 6 minus -12 to get 18. Instead of 4 plus -4 to get your displacement of 0, you did 4 minus -4 to get 8. Okay? All right. Let's look at 40e to the -x sine x minus 5, and let's calculate the displacement and the distance. I might change up my interval just so it's a little bit easier to do. I know. This is my favorite, apparently, 40e to the -x sine x minus 5. I might change up my window. Let's start from 0 to 4, and then I might change my mind. Oh, it's not gonna be nice unless I change it from like 0 to 1. Whatever, let's do it. All right, so find the displacement from 0 to 4. with a calculator, thankfully, right? All right, easy. What's all that area from 0 to 4? Don't forget what this tells me. It tells me the change in your position, where you end up versus where you start, 0.516. Great. So I end up at t equals 4.516 units to the right of where I started. Now, I am not given any initial position, so like I don't know what my position is at time at 4, but at least I know the change in position. All right. How are we going to find the distance? Tell your neighbors, what would you do? Debner, tell your neighbors what you would do. Yeah, exactly. We would understand that my velocity is negative until this value A. Right? My velocity is negative until A. It's then positive to B, then it's negative after that. So if I just split this into just a bunch of different sections and understand the displacements of all of those sections, make all those displacements positive and I'll have a distance. All right, let's quickly find A and B. And I'll store it as A and B in my calculator, second calc intersect. Let's pop over to, I guess we'll do B first because it's right there. Enter, enter, enter. B is at 1.989. Okay. I'm going to store that as B. Now 1.989 is B. Let's find A. Pop over to the other intersection, which looks to be close to 0, so some decimal. A is 0.145. Let's store that as A. X, I want to store as A. Great. And now let's find all the displacements, starting from 0 to A. Well, I know that's going to be a negative displacement. I'm going to want to make it positive. What do I do to make that negative displacement a positive? Yeah, take the opposite of it. So I got math 9. I'm going to go 0 to A. This is why I like to store things. 40 e to the negative x, sine x, minus 5. And I'm going to use that over and over again, so it's good. So then again, that negative 0.343, this is how far I went left. Left, negative 0.343. Make that an opposite, it'll be a positive distance. Then I will add my positive displacement, so it stays as a positive distance from A to B. Okay, so let's go from A to B, and then I get to go from B to 4. It's showing you how, you know, it's a little bit involved, a little bit intense, but it'll be fine. So I'm going to go right 9.009. That's that displacement. And then I end up going left from B to 4. I can find that area, but then I would take the opposite of it. So that I'd be adding a positive B. Let's go B to 4. This is telling me how far I've gone left. I go left 8.148, or I decrease. To find my distance, here we go. Take that first number, make it negative, or make it positive. Take the opposite of it. Okay? Add that positive 9. Subtract the negative 8. Boom, 17.501. Let's call it 502, because it's very close to it. That makes sense? All I did was take this 9, add it to this 8 as a positive, add it to this 0.343 as a positive. Cool? You add those numbers together, you get 17.502. Nothing new. Is everybody cool with that? Was that involved? Sure. Is there an easier way to do this? Actually, yes. Okay. Let's go back up a little bit. Let's get that number 17.502. And you guys all gave up because I was going too fast. So I want you to get to 17.502 yourself so that you know, oh, I can find distance and it's going to be okay. This class is not that bad. Well, what have I been doing? I've been taking things that were negative. I'm making things positive. I'm taking things that are positive and I'm keeping them positive. There's some sort of operation in mathematics where it's like, take negative things, make them positive. But take a positive thing, keep it positive. Tell your neighbors, what's that thing? Thank you. Okay, well, what your calculator is doing here in this integral is accumulating velocities times time, okay? And that's displacement. Velocities can be positive or negative. Well, I want my calculator to accumulate speed times time, okay? Speed times time. Speed does not care about direction. And speed times time is going to give me a distance. Distance equals rate or speed times time. Well, here is your magical calculator formula. Your magical calculator formula is to just turn velocity into speed with an absolute value. Okay. This can be done with a calculator. If you don't have a calculator, you need to understand when you're going right. You need to understand when you're going to left. You need to set up multiple integrals so that you can add things only as positive. That's no calculator. Calculator, hip hip hooray. All right. Can you get this number 17.502 with just one integral from 0 to 4? Quickly. Go. Wait, you guys know how to type in an absolute value into your calculator? Math, number, ready? Math, pop over to num, you got add. Num add. Now, what's important is that the adds are going inside your accumulation, not outside. Because if you take it outside, it's just going to make this 0.516 number, and if it was negative, it would turn it into a positive. So it's got to go in the inside so that we're accumulating speed times time. Now, you're going to notice something. Mr. Messner, it appears my calculator's not working. I broke something. Nope. Not 0 to 9. Okay. Not that you broke something. It's that your calculator is doing a bunch of calculations and kind of complex things with some sharp points because of the absolute value. It needs some time to do this accumulation. It is doing a lot of arithmetic really, really quickly. It seems like it's slow. But to this calculator, and it's doing like not much, but it's doing a lot. You see this little line moving? It means it's working. Boom, 17.502. Okay? Got it? So, here's what you're going to do. When asked to find distance, let's say you don't have a calculator. You hate your life. And you're like, well, it's going to be okay. Probably this is one part of many. And probably over the course of the problem, I'm going to have to evaluate my velocity anyways. I'm going to have to see when it changes sign anyways. And this will just kind of follow along into what I've already done. Is that cool? So I'm going to have to set up multiple integrals. Maybe if it's positive, keep it positive. If it's negative, make it positive, and you got to do all that work without a calculator. Now, hopefully they ask you to just set up integrals. I will, instead of set up then evaluate, because then that would be even more work to then, without a calculator, have to take antiderivatives and plug things in. But if you do have a calculator, and I ask you, what's the distance? Okay, get the distance. Hey, you guys find it that way? I'm going to find it the hard way. Factor out -1. That's t squared minus 6t plus 8. So that's t minus 4t minus 2. Okay, so this is going to be 2. This is going to be 4. This is actually going to be negative, positive, negative. So I actually need to go from 0 to 2, make that displacement positive. I need to go from 2 to 4, keep that positive displacement positive. And from 4 to 5, take that negative displacement, make it positive. I would have to do all of this without a calculator, at least the setup. I took my velocity, I analyzed the signs, I found the zeros on my velocity, blah, 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 blah. If I typed in these 3 integrals, and we don't have time to do it right now, but if I did, I'd get the same as if I just math 9, 0 to 5, accumulate some speeds, calculator. I ain't got time for all this analysis. And you get, wait, did you guys get that? Oh, I forgot a -8. My bad, my bad, my bad. Yeah, changed it that much. Now, word of the wizard, and notice what's going on with your calculator. It wants to be like 9 1/3, but then it's off. Why? What your calculator does, this accumulation process, it's approximating, just like it approximates derivatives. So it's probably telling me it's got 9 1/3. And sometimes when you do it with an absolute value, because there's sharp points on the graph of an absolute value graph, your calculator, loses a little bit. I'm just going to go ahead and do it just for fun because I have this. Oops. It's easy to get rid of an absolute value. It's hard to add it in. So word of wisdom there. We got 0 to 2. I got 2 to 4. Not that bad once you have it in. 2 to 4. Again, this would be like what I'm doing without a calculator or what I'm doing without an absolute value. 4 to 5. 4 to 5. Okay, I'll take the opposite of my negative values. I wonder if that works. We'll see. Keep my positive value. Take the opposite of my negative values, and I'm going to get 9.333. Cool? All right, cool. Great, that's distance. Moving on. Oh, just be careful. Like, if you're given acceleration, remember, v goes in here. If it's without a calculator, don't forget, you have to take the antiderivative to find displacement. Okay? So don't forget, no calc, that means antiderivative. With a calculator, that means accumulate. All right, now I'm going to completely change your conceptions of what an average means. What do you guys know about averages from like middle school, probably even elementary school, sometimes in high school? Means. Yeah, don't think of it anymore like that, okay? Not in this class. You can go back and take stats class, yeah. Add up the number of things, divide by the amount of things that you have, that's fine. So for this class, guys, if I'm asking you for an average of something, this is what you're going to do, okay? This is new. This is your new understanding. Of average. Now, first things first, This is not average rate of change, though it actually is. I'll show you. Average rate of change versus an average of something, two different questions. Okay, two different questions. Average rate of change, relative to secant. Average of something, we'll see what that is. And actually it's going to go take us back to lesson 1. When we talked about, if I have position, how can I get velocity here? What's like the connection with calculus and physics? And we actually started with average velocity. And we said, well, if I knew the change in my position, over the time period in which those positions changing, this is an average rate of change of position. That gave me an average velocity. Well, it's actually from this formula that I'm going to come up with a new formula for average. Because after lesson 2, I know there's something else that can be used for x of b minus x of a. All right, you guys know x of b minus x of a is what? What's a word for x of b minus x of a? Displacement. Thank you. This would be our no calculator of calculating displacement. What's our other way of calculating displacement? Using an accumulation of velocities. The calculator can accumulate velocities. Well, I'm going to take this and replace this. And I am going to come up with a formula. Move the b minus a out into the front. I'm coming up with a formula for average v. This means average. Now, it's kind of like what you guys think about with average. Add up all the numbers, divide by how many numbers you have. Well, what does this integral mean to a calculator? Accumulate. Add up all the velocities. Don't divide it by the amount of velocities we have. We divide it by like the interval in which we're taking those velocities. Kind of makes sense. Kind of intuitive to your understanding of average.
In general, does it matter if like the A or B is on top?
Yes. Keep A on the bottom, keep B on the top. We'll talk about how direction does matter next unit. We're keeping everything like A to B. Smaller, bigger. Okay? Now, this means if I wanted to find the average of something, okay, like position, like acceleration, like velocity, like F, you're going to go 1 over B minus A, integral from A to B of whatever that something is. This is your new understanding of average. If I ask you for an average in this class, find the area, multiplied by 1 over B minus A. Okay, find the accumulation of that something. Okay, if you have a calculator, easy. Type this in, done. If you don't have a calculator, well, you'll find that you would have to take the antiderivative, that it ends up being an average rate of change, and it's an idea behind the whole average rate of change equaling averaging. But most of your questions will involve just a setup, or just like using your calculator. So, but not always. So let me show you. Like, here's a position. You have a calculator. Find the average position. Okay. 1 over B minus A, integral A to B of what I'm trying to find the average of. Boom, type that into your calculator. You just get the average position. You do it, I'll do it. Now, to you, this means take the antiderivative. To your calculator, it means accumulate. A lot of people see like X, and they feel like, oh, I need to take the antiderivative. No, like you plug in X where you see it. If you were to do this question without a calculator, you would have to take the antiderivative. But since I do have a calculator, I'm just going to go 1 over 3, math 9, 1 to 4 of what I'm trying to find the average of. T cubed minus 3t squared plus 6. Boom, 6.25. Now, I may, for a no calculator question, ask you to find the average. Well, that's when you would have to set up your integral, and this is a calculator, easy, without a calculator. Set up your integral and understand to evaluate your integral, you would have to take the antiderivative. Don't worry about the plus b because you're going to subtract. You'd have to plug in 4. You'd have to plug in 1. Lots of arithmetic. But that's what we have to do with that calculator. That was a genius discovery by Newton. How you can use antiderivatives to find accumulation. Okay? And then like yada, 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 6.25. Okay? A lot of yada, yada, yada's there, but you get 6.25. Right? Calculator, no calculator. Setup is the same. Just remember, without a calculator, don't forget to take the antiderivative. Don't just plug in 4 into this and 1 into this. Okay? Finish things off with being careful. I sometimes am cruel on you. I give you a velocity, and then I ask you to find the average position. You will have to find the position function. Okay, that's easy. T squared minus 5t plus c. I got x of 0 is 1. You guys remember how sometimes we had to find c? Boom. But then I ask you to find the average position. And you're like, okay, 1 over b minus a, integral from a to b of t squared minus 5t plus 1. No, you don't find the average position using velocity. You find the average position using position. Now, here's where a lot of students fail. You already took an antiderivative of v. You got x. You just put x into your integral. Good setup. People don't like to take antiderivatives twice. I don't know why, but for some reason, like the previous question, people know, oh, I have to take an antiderivative. For this question, a lot of people take that 2 and that 0 and plug it in here. But for this question, we had to take an antiderivative of v to get x. And then to find the average x, we're going to have to take the antiderivative again. Plug in 0, plug in 2, the c will go away. Be careful, guys. Understand what you have to do when you have a calculator. Understand what you have to do when you don't have a calculator. Okay? Now, let's finish off. Let's see if you really understand. Here is velocity, change this area to 2. What's the distance the object traveled from 0 to 6? What's the average velocity of the object from 0 to 6? We'll start with distance. Here's the velocity. What's the distance? 10. How'd you get 10? 2 plus 4 plus 3 plus 2, right? That's the whole absolute value idea. Negative displacement. Good. Good. So 4, 5, 6, 7, 8, 9. It's 11. I changed the 1 to a 2.
Yeah,
What's the average velocity? Nobody's leaving until somebody answers this. What's the average velocity? Nope. William, don't look for somebody else. Somebody's counting on you to get this answer. So many of you are just waiting for somebody else to do it. Somebody needs to do it. Not 9/5. Make sure that's 2. Nope. Nobody's leaving. This is going to be like the first day Stengel is going to be on time to his second period class. What'd you get?
11/6.
Not 11 over 6. Not 11 over 7. Oh, man. Well, if we remember average of something, I'm not going to give you the answer, would be 1 over b minus a, integral from a to b of what we're trying to find the average of. Maybe that'll help you guys. It is just 1/6 because 0 to 6 is the displacement. It's -2 plus 4 minus 3 plus 2, which is 1. You have 1/6 times 1, and all y'all who just waited, waste of your brain, all that waiting. You could have gotten that answer 2 minutes ago. You should get extra credit. You're the only one who tried. Everybody else is just guessing.
Wait, how did you get the second part?
This is the area under V. -3 plus 4 minus 3 plus 2.
Oh, okay.
It's 1.